Okay, this is section 10.4, day 1, and today we're going to start talking about inscribed angles and polygons. So we're going to start putting things inside of the circle. And so to start with that, we're going to be able to talk about inscribed angles of circles by the end of the lesson. An inscribed angle, kind of underline that in part, just means it's an angle that has, an inscribed angle is an angle with vertex on the circle. Okay, so the vertex is on the circle, and then the two sides of the angle are chords or potentially secants going through the circle. So this is the inscribed angle. Okay, so it's sitting on the circle. That's different than a central angle, which we've already done, with where it has its vertex at the center. So it's a different angle, kind of pulling it across the circle and landing it right on top of the circle. Okay, we also have something called an intercepted arc. That's the arc that, an intercepted arc is an arc cut off by the inscribed angle. Or I should just say by the angle, because it could happen for any kind of angle. This right here, this is the intercepted arc. So that's the arc that this angle cuts off. Okay. So onto your theorem card, we've got a couple of theorems today for 10.4. The first one, let me zoom out here a second. The first one is right here. And this is dealing with our inscribed angle. So anytime there is an inscribed angle, it's going to be half the measure of its arc. So an inscribed angle is equal to half the arc. I probably should throw in the measure. Let's do that instead. The measure of an inscribed angle is equal to half of the arc. What that means is the measure of angle ADB, talking about this guy right here, is going to be half of the arc that it cuts off, so from A to B. So if this guy is 50, then that is 100. Okay, so the angle is half as big as the arc. The second theorem has to do with kind of overlapping angles, or angles that share an arc. So if two inscribed angles intercept the same arc, then the angles are congruent. So what that means is in this picture that we have, the measure of angle ADB is going to be congruent to the measure of angle ACB. So this angle right here is equal to this one. And the reason why is, if you look at this angle, angle C, this ACB right here, it cuts off this arc. And angle ADB cuts off the same arc. So since they cut off the same arc, they have to be the same measure. Okay, so those are the two big theorems we're going to work with today. Coming back over, we're just going to do a couple of problems. First one says find the indicated measure. First we're going to find the measure of angle T. So we're looking for that guy right there. So what I kind of tell kids to do is take two sheets of paper, just two scratch pieces, what I'm trying to grab right here that I'm struggling with. And I kind of put it on the edges of that angle. So here's the first side of angle T and here's the second side. And it kind of gets rid of all the extra stuff you don't need. And so by looking at this, I can tell that angle T cuts off the arc of 48 degrees, which means that angle T has to be half of that, so 24. Finding the measure of arc QR. So QR is right here, from Q to R. All right, looking at that picture, I see this 50 right here. So I'm going to do that same trick again. I'm going to kind of mark off the sides here. And so if that angle is 50, then I know that this arc has to be 100. I know that this is a diameter going right through the center. So 180 degrees from there to there. And I'm already using up 100 right there. So that means that there's got to be 80 degrees left for that arc. Moving on to the next one. Let me zoom in a little bit. Find the indicated measure of this arc. Oh, sorry, first one. Oh, geez, I think I meant arc here. So arc RS, we're talking about this guy right here. So I'm going to kind of do my angle thing again. So there's 31, and the other edge to 31 is right there. So that makes its arc 62. Next is an angle STR, so S, T, and R. So I'm looking for that right there. And if you kind of do that same trick, you find out that it goes with the same arc. It's also with arc SR. which is the same as this guy. So if they go to the same arc, then they have to be the same measure. So angle T has got to be 31 degrees. Next one, find the measure of the arc or the angle. And I clearly forgot to label these. So let's talk about the measure of angle G. So if this guy is 90 degrees, then angle G is going to be half of it, so 45. Let's talk about arc TV here. So TV, we'll go with the measure. So if that's 38, then across from it, the arc has to be twice as much, so we'll double 38 and get 76. Last one, let's talk about angle X. So talk about that guy right there. Since Y, which is right here, cuts off this arc, 72 degrees, so this would be 144. And then when I go back to angle X, which uses the same arc, I have to be half as much, so 72. They're going to be the same measure. So two big things today. If I have two angles that share an arc, they're the same measure. And my inscribed angles are half as long as their arcs.